Hey guys, I'm on a field trip with Jack today, so I hope you have fun without me. Today we're just going to take some notes about parallel and perpendicular lines. So get your notebook out, and then as the video goes on, you can pause it if you need to catch up. So let's talk about parallel lines first. Okay, so some things that we already know about parallel lines is that they never intersect. And then what you learned last year and this year is that they have the same slopes. Okay, so underline that or highlight that. We know that also they're coplanar, but today we're going to focus on the fact that they have the same slopes. Now with perpendicular lines, whoops. We know that they intersect to make a right angle. And we know, also we reviewed this at the beginning of this unit, that they have opposite reciprocal slopes. Okay, so let's talk about what that means. The opposite means that you're going to go from positive to negative or negative to positive. And reciprocal means that you flip when you have a fraction. So if you have 2 over 3, the reciprocal of that is 3 over 2. So to get the slope of one line to a line that's perpendicular to it, you're going to make 2 changes. First go positive to negative, then flip the fraction. Let's do a couple of examples of what that's going to look like. So if I give you a slope of 1/2, remember this symbol means perpendicular. The slope that's perpendicular to that is, since this is positive, it would be negative. And if I flip that fraction, it becomes 2 over 1, which is the same as 2. If I have a slope that's -3, remember that's really the same as the fraction of -3 over 1. So the perpendicular slope to that would become positive because this is negative, and then the fraction would flip, so it would become 1 over 3. So those are some examples of slopes that are perpendicular. Now I'm just going to do a little reminder so you can write these forms down because you're going to need them today. So the mostly used equation of a line that you learned last year is slope-intercept form. Try to think of it before I write it down, but you guys should recognize it. Y equals mx plus b, where the m is your slope and the b is your y-intercept. Then you should have also learned last year point-slope form, which is a little bit longer, but that's the one that's y minus y1 equals m parentheses x minus x1, where m is still your slope, and then the x1, y1 is a point on the line, any point on the line. Then the last form that you learned last year, and if I went too quick, you can just pause and rewind the video as needed. The last one that we did is called standard form. And that one is ax plus by equals c. Now we're not going to use that one as much to just look at it and see the slope because we don't get slope information from looking at standard form. The only one that we can actually get the slope information from is point slope form, where it's right here is the slope, and then in slope intercept form, the slope is right here at the m. Okay, so the way that we're going to apply that to geometry is the first thing that we're going to do is you're going to have to look at 2 lines and decide if they're parallel or if they're perpendicular or if they're neither. So neither would mean they're just intersecting or they lie right on top of each other. So write these directions down, please. So are the lines parallel perpendicular or neither. So take a minute, pause the video if you need to, make sure you have the directions down because that's what you're going to see on your homework and then also on the study guide for your test, which is next week. So you'll be given some information. Let's say your first line is 1/2 x minus 4, and your second line is 1/2 x plus 8. So when you see equations like this, the first thing you want to think is to decide what form they're in. These are in slope-intercept form, so we can easily pull out the slope. My recommendation is to write the slope off to the side, so it's easier to compare. So now it's clear to see that those slopes are the same. So these lines are parallel. And you know that because you have the same slope. Okay, so the first kind of problem you're going to see, the slopes will be the same. You're just comparing the two. If they're exactly the same, then the lines are parallel. Let's do another example. Let's say that line 1 is y equals 2/3 x plus 4, and the second one is y equals -3/2x minus 6. So once you write them down, before I write them down, try to pull out the slopes just like we did in the last one. So in the first one, the slope is 2/3. I'm just getting that from right here. And then in the second one, the slope is -3/2. So remember before I said you have to make two changes if the lines are perpendicular, because we can look at these clearly and see that they're not the same. So did we go from positive to negative? Yes. And did we flip from 2/3 to 3/2? Yep. So these lines are perpendicular. And then we can just say the slopes are, whoops, can't spell, opposite reciprocal, and we can abbreviate it like that. So since we go from a positive to a negative and we flip the fraction, then you know the lines are perpendicular. Let me show you one more example of how they might try to kind of trick you, so you have to pay attention to the details. So let's say your first line is y equals 3/5x plus 1, and let's say your second one is 5/3x plus 8. So again, the first thing I want you to do is always write the slopes to the side so that you can compare them easily. So the first one's 3/5, and the second one's 5/3. So you can pretty clearly see that they're not the same, so we know they're not parallel, but if you notice, they flipped the fraction. They made the 3/5 5/3, but they did not change the sign. So this is then going to be neither. But it's kind of a trick to make you think that it's perpendicular because the fractions flipped, but the signs are not different. So make sure that you're being careful and you're paying attention to those little details. Okay, now we're going to do a couple of examples where I'm also going to show you how you can do this on Desmos, in case it's not in slope-intercept form. If it's in slope-intercept form, that's easy just to look at and see the slope, but sometimes it's not. So let's say the first equation that we get looks like this. So if I asked you what form that is, you should be thinking to yourself that's standard form, because you have the x term first, then the y term, then the number by itself. So that's standard form, and remember, we can't look at standard form and see the slope. So that one we're going to have to type into Desmos so that it'll be easier for us to compare to the second line. So let's say the second line is y equals 3/2x plus 6. Okay, so once you write those down, I want you to take a minute, pause the video if you need to, and open up Desmos in another window. And then we're going to type them in and just look. So in the first line, we're just going to type in 2x plus 3y equals 5. And then in the second line, we're going to type y equals 3 over 2x plus 6. All right, so now if you look at the lines, and you can zoom out if you need to, or you can move the graph around. If you look right here, doesn't that look like a 90-degree angle? So we're looking right here to see if that's a 90-degree angle or not. Now, if we want to count to make sure, the best thing to do is to look at the red line and see these points that are on here. We want to use them, the whole numbers, to count a slope. So it looks like this red line, if we count from here, this point right here, to this point right here, because you can see these are on halves, so that's not an exact point. And this point here, we have a slope where we're going down 2 and over 3. So the slope here is negative 2 over 3. Then for the other one, we already know that the slope is positive 3 over 2. So if we use this point here, and this point here, and this point here, we're going up 3 over 2, up 3 over 2. So if we look at the slope of 3 over 2, aren't those opposite reciprocals of each other? So if they are, then we know that those lines are in fact parallel. So when you have these questions and you don't want to do the work with the standard form to put it into slope-intercept form, you can just type in any form in Desmos and it'll give you the answer. Let's do another one where they're parallel just so you can see what it looks like. So first write down, say these were perpendicular. Okay, and on a test or a quiz, you can always just write that those are, that you put it onto Desmos. But let's look at another one that's parallel. So let's say your first equation is 4x plus y equals 3. And your next equation is y equals negative 4x plus 8. So let's go back to Desmos and just type those equations in. Okay, so we're just going to type this one in. Let me erase those numbers there. So we get 4x plus y equals 3. And then in the next equation, that one's already in slope-intercept form, but we can type it in, plus 8. And then you can see, if you look at them carefully, that those are in fact parallel. And if you want to zoom out, you can kind of see that they're not going to intersect. And again, if we want to count the slope, we can look at this equation right here and see that the slope should be negative 4 over 1. So if we want to look at the red line and compare, if we're going from this point down 1, 2, 3, down 1, 2, 3, 4, and over 1, aren't we still on the line? Or if you count up 1, 2, 3, 4, and over 1, then we're still on the line. So we know that that slope of that red line is in fact 4, and we can look at the equation to see that the slope of the green line is in fact 4. So those are parallel. Okay, so that's the first type of question that you're going to have to solve, is you're going to be given two equations and you're going to have to tell me if they're parallel, perpendicular, or neither. Now the other kind of problem that you're going to have to do, you're going to have to write an equation. So take a minute, write your directions down. Okay, so take a minute, pause the video if you need to write down the directions. This says write an equation of a line that is parallel to y equals 1/3 x plus 1 and goes through the point 6, -3. Now when you're approaching these problems, you're going to have to look at what they give you. And here they give you a point. And if you look back at the first slide that we did with the different forms on it, if you look here, they're named to kind of help you. This one, slope-intercept form, gives you a slope and an intercept. Point-slope form gives you a point and a slope. So you have to look at the information that's given to figure out which one makes the most sense. Since we have a point, the one that makes the most sense is point-slope form. So let's go back to our example. And we're going to use point-slope form. So write it here for your reference. Y minus y1 equals m parentheses x minus x1. And we're just going to fill in 3 numbers. So the numbers that we're going to fill in are the y1 right here and the x1 from the point that we're given, and then the m. Okay, so we have the point. Now we have to pull the slope out. This part right here gives us the slope information. So if you think about what we know about parallel lines, we know that they have the same slope. So if it's parallel to this line in the box, then that means the slope is going to be the same. So we're going to pull out that slope, and then you're going to cross off the equation because this one right here, this one, you don't need it. Okay, so I'm crossing it off because we're not going to use that. We just need the slope from that equation. And now we're going to plug in. So this is our x1 and our y1, and then we've already defined our m here. So now we're just going to rewrite this equation substituting those numbers. So this y always stays a y. And then if we're putting in a minus and -3, that's going to turn into a +3. And then your m we know is 1/3. You're going to do a parenthesis, x, and then we're looking at our x1, and that's 6. So that's your equation. Now, if it doesn't specify that you need to be in a specific form, then you're done. That's it. You don't have to do any work. You're just done putting it into point-slope form. So let's do one more like that. Okay, same directions, but instead of writing them all out again, I'm just going to give you the information. So we're going to say perpendicular to y equals 2/3 x plus 1 and goes through the point let's do one that's not the same as before, -5, 2. Okay, so here's the 2 pieces of information about our line. We know that it's perpendicular to that line that I wrote, and then it goes through the point, -5, 2. Okay, so again, you're going to decide which form that you're going to use based on what they give us. So they give us a point here. So they give us a point. So that's your clue that you're going to use point-slope form. So now what we need to do is we need to find the slope. So again, we're looking at this equation here to find the slope. And since we know it's perpendicular, we know it has to go from positive to negative. And then you're going to flip the 2/3 so that it's -3/2. And then we're going to cross this equation off because we don't need that 1 and we don't need the 2/3. We just needed to take the 2/3, get the opposite reciprocal, and then we can write it into point-slope form. So y minus 2, and I'm getting that 2 from right here. Let me label this, x1 and y1, equals, and then we're pulling our slope. So -3/2, parentheses x, and we're doing minus -5. So it turns into +5. Okay, so those are the 2 types of problems that you're going to have to do on the test, which is next week for you guys on Thursday, if you're in first period. So you'll do some practice of those on the study guide, and right now the sub's going to give you a practice worksheet to go over those problems. So complete the practice worksheet. You can look back at your notes. You can watch the video again if you need to, and then get the sub to check it. And then you're going to work on your study guide and actually come back. I made another video that's walking you through some of the answers on the study guide so you have some examples of how to do those different problems. Thanks for listening.